The standard quadratic form is y equal to ax squared plus bx plus c. Define the parabolic curve. The coefficients a, b, and c are the direct determinants of its graphical representation. A establishes the direction and the magnitude, while b and c dictate the vertex and the y-intercept positioning. This precise visual correlation reinforces the equation's inherent structure, yielding the visual parabola. Coefficient variation produce diverse parabolic forms. Parabolic forms derived from quadratic are integral to structural and design principles. They provide inherent stability and aesthetic value evident in bridge and dome constructions. This exemplifies the equation's practical manifestation beyond theoretical construct. Beyond the standard form, alternate representation exists: vertex form and intercept form. Vertex form elucidates the parabola apex, and the intercept form its roots. Each form provides distinct analytical advantages, essential for comprehensive mastery. The name each form tells us exactly what is this form is useful for. So let's start by the vertex form. The vertex form is y is equal to a multiplied by x minus h squared plus k. So let's start with the a. If a was greater than 0, this means that the parabola opens upward, and we usually call it a happy face. And if a was less than 0, the parabola opens downward, and it's called a sad face. While h and k represent the vertex of the parabola. See this point right here at 4 and -2. This is the vertex of our parabola. It's like the parabola's special spot. It's a turning point. So we can say that the primary purpose of the vertex form is to make it incredibly easy to identify the vertex and the direction of the parabola. Next, we need to understand how to get the vertex form out of the standard form. We're gonna start with the standard form. If we have y is equal to ax squared plus bx plus c, the first thing that we need to do is to factor the first two terms, which is ax squared and the bx, and take a as a common factor, and we will get y is equal to a multiplied by x squared plus b over ax, close your bracket, plus c. Next, we need to complete the square inside the bracket. If you're wondering about completing the square method, click on the link up there. Basically, we are taking the coefficient of x, dividing it by 2, and square that. Then add and subtract that to the terms that we have. So we will have a multiplied by x squared plus b over ax. This is the coefficient that we're gonna take and dividing it by 2 and square it, plus b over 2a squared minus b over 2a squared. Enclose your bracket at c. And that's it. We are done completing the square. And the purpose over here to complete the square is to write it in a perfect square trinomial. So we will have multiplied by x plus b over 2a, all of that squared, minus b over 2a squared, close your bracket, plus c. Then we need to distribute back the a. We're gonna have a multiplied by the first bracket minus a multiplied by the second bracket, plus c. The next step is to simply simplify that equation. So we will get a multiplied by x plus b over 2a squared, and we're gonna leave this as it is, minus a multiplied b over 2a squared. This is the terms that we need to work on and to simplify a little bit. So first, we're gonna apply the square. So we will get b squared over 4a squared. Then we will multiply this by a. In order to multiply this by a, we will get b squared over 4a plus c. And by that, if you compared between the equations that we have now to the vertex form that you see at the beginning is very similar. With that, we can say that h is equal to negative b over 2a and k is equal to negative b squared over 4a plus c. So in order to find the vertex form or the vertex for the parabola, you need h and k. Or basically, you need the standard form, and from the standard form, replacing a, b, and c and the values for h and k, you will get a direct h and k, which is the vertex for the parabola. Having concluded our exploration of the vertex form, we now shift our focus to the intercept form. This form offers a straightforward approach to understanding a parabola's x-intercepts, which are the points where the graph intersects the x-axis. The intercept form, as its name suggests, directly reveals these intercept points points by simply examining the equation. We can identify the values of R1 and R2, which indicate where the graph crosses the x-axis. These values correspond to the coordinate R1 and 0 and R2 and 0. Alternatively, we can use the variables P and Q represent the intercepts, resulting in the points P and 0 and Q and 0. Thus, any parabola will have two x-intercepts. Now, how do we obtain the intercept form from the standard form? It's a remarkably accessible process in algebra. Essentially, we recognize that the intercept form can also be referred to as the factorized form. This implies that we need to factorize the standard form. We have two primary options: direct factorization or the quadratic formula. Direct factorization technique includes the AC methods or factoring by grouping. If the quadratic expression is not factorable, we can utilize the quadratic formula to determine the roots, which are equivalent to the x-intercepts. That concludes our exploration of quadratic equation forms. I encourage you to explore further and practice applying these concepts. Remember, mastering quadratic equations unlock a deeper understanding of mathematical principles and the real-world applications. Leave your thoughts and questions in the comments below. I would love to hear what you think. Bye-bye.